Today we will discuss the steady state behavior of forced oscillator. That is second part, steady state behavior of a forced oscillator. As you know, there are two types of behaviors which have been shown by the forced oscillator. First one is transient behavior and second one is steady state behavior. So, in case of transient, there is no external periodic force, and in case of this steady state, the external force and external periodic force is applying on the oscillator. So, steady state, in this case, steady state case, the equation is that is m into d square x upon dt square plus r dx by dt plus sx is equal to f naught e power iota omega t. So, this is the equation for steady state behavior. Now, we will solve it or solve this equation. As you know, this is second order differential equation and the solution of this equation is very complex in nature. So, we have to assume that the solution of this equation is complex in nature. So, let the solution of this equation is in the form of x is equal to e power iota omega t. So, solution is also in the terms of iota. Iota means complex in nature, imaginary or complex nature. So, this is the solution which we have assumed. So, why this type of solution is assumed? Because it is second order differential equation and solution is also very complicated or complex. So, this is the solution, you have to remember it. Now, if this is the solution of this equation, then we know that this solution must satisfy this equation. So, this equation or this solution must satisfy above equation, that this equation is number 1. So, we have to put this value of x in this equation and finally, we will get the answer. When we put the value of x here, so this is the second derivative of x. So, we have to take the second derivative of x. In this case, first derivative, here x is as it is. So, x is as it is, we will put this value here and we will take its derivative. So, taking the derivative of this equation dx by dt is, that is a e power iota omega t. You know that a is constant and the derivative of e power iota omega t is e power iota omega t into iota omega. So, ultimately it is iota omega a e power iota omega t. So, this is dx by dt. Now, again differentiating this equation, we will get d square x upon dt square. So, we have to take the derivative of this equation again, that is iota omega into a e power iota omega into iota omega again. So, it is iota omega into iota square omega. So, you know that iota square is minus 1. So, it is minus omega square a e power iota omega t. So, it is clear because iota into iota is iota square, that is minus 1, because iota square is minus 1. So, I have put this value iota square is minus 1. So, this is the value of x, this is the value of derivative of x and this is the value of second derivative of x. Now, put all these values in first equation. So, putting this values, these values in this equation, we will get m into the second derivative, this minus omega square a e power iota omega t, okay, and plus r dx by dt is this, that is iota omega a power iota omega t and plus s into x, x means a e power iota omega t is equal to f naught iota omega t. So, we have done this step, that is, if x is the solution of this equation, then this x must satisfy this equation. So, on putting the value of x, first derivative, second derivative, we get this simple equation. Now, we will simplify this equation. Now, taking the common, that is a is common, okay, e power iota omega t is also common on left hand side. It is minus m omega square is here and plus iota r omega is here and plus s, because a e power iota omega t, a e power iota omega t, a e power iota omega t is common. And right hand side it is f naught e power iota omega t. So, e power iota omega t will be cancelled on both sides and the remaining equation is a into this minus, or we may write this iota term first, iota into r omega, okay, and plus s minus m omega square is equal to f naught. So, this is the remaining part. Now, we will find the value from this equation, value of a, this is a. So, this is a. So, a is f naught over iota r omega plus s minus m omega square. This is a. Now, we will rearrange this equation or this denominator as like it. We will take common from here. We will take common iota and omega. We will take iota omega common from the denominator part. We know that iota and omega is not common in denominator part, but it is a compulsory step. You know that a compulsory step, and we will take out iota omega as common. So, you know that when something is common, then we have to divide in the other terms within the bracket. So, iota omega is common, iota omega is common, r is here, because I have divided this iota r omega divided by iota omega, it is r. And similarly, this is s and iota omega and minus m omega square upon iota omega. Is it clear? Because iota omega is, I have taken this common, this term. So, we have to divide by this iota omega, this one, sorry, r, that is iota omega, I have divided iota r omega upon iota omega is cancelled and it is not, there is no any iota and omega. So, I have divided this s upon iota omega and minus this. So, omega is cancelled with this and we will get this f naught over iota omega common and r s over omega and 1 over iota is minus iota. You know that 1 upon iota is minus iota. You know that this type of algebra or complex number we have already studied in the lower classes, and this is m omega and 1 upon iota, again minus iota, so minus into minus plus iota, this one, okay. Or we will rewrite it, that is iota omega is as it is r and we take iota common plus iota common and it is m omega minus s over omega. So, this is value of A. By doing this, I have taken this common iota omega and the remaining term within the bracket, this is nothing, it is impedance. So, to make it the term like as impedance, we have taken the common iota omega from the denominator part. So this is A and it is F naught, and 1 upon iota is minus iota, okay, into omega. So F naught is F naught and omega is omega, and 1 by iota is minus iota, and this one, it is impedance Zm. So I have put this R plus iota m omega minus s by omega as Zm. So what is this? This is nothing, it is just like as impedance. As you know, in case of LCR circuit or in electrical circuit, this is R plus omega L minus omega C, or sorry, XL minus omega XC. So it is same as impedance. So this is called mechanical impedance. So this term is mechanical impedance, means the collective resistance observed in case of mechanical oscillator, means this is the overall impedance, that is overall, this is obstruction, or this is resistance in the path of mechanical oscillator. So it is called mechanical impedance. So this one. So this is the value of A. Now the solution becomes, the solution which we have already taken, that x is equal to A e power iota omega t will become as the value of A is minus iota f naught over omega Zm into e power iota omega t. So this is the solution of second order differential equation. Now we will discuss this impedance term, in detail, and then finally we got the exact solution of this equation. So now first of all we will discuss discussion on impedance. We will discuss this impedance in detail. So what is this impedance? This is Zm is equal to R plus iota omega m minus s by omega. And first part is real part and this is imaginary part. So this is impedance consisting of complex number, that is real and imaginary part, and we will take this real part, Z real part, this one real part, as Z cos phi, or it is Z cos phi. So I will compare this impedance as complex number. You know that complex number is that number having cos component plus iota sine component, like this. So it should be cos component and it should be sine component. So therefore, on comparison with the standard equation or standard complex number equation, that is this real part is Z cos phi R. So I put this R as Z cos phi, and the second one is omega m minus s by omega as Z sin phi. So these two terms consisting of complex number, real number is this, imaginary number is this. So this is imaginary number and this is real number. Now this R, if we divide this imaginary number, imaginary part with real part, that is Z sin phi upon Z cos phi, it will, sine means m omega minus s by omega over R, or Z cancel, sine upon cos will become tan. So tan phi is m omega minus s by omega upon R. So this is tan phi. Or if we compare or square and adding these two parts. So, we will get z square because z square cos square phi plus z square sin square phi. I am squaring this left hand side and adding. We will get z square on left hand side is equal to r square plus m omega minus s by omega whole square. Okay. And finally, z will become this. So, this is the value of z and it is value of tan phi. So, this complex number may also be written as Zm is equal to z into e power iota phi, this type, because when we open it, it will become e power iota phi means cos phi plus sin phi. It will become Zm cos phi plus iota Zm sin phi. So, this is the impedance. So, we will replace this impedance as the coefficient of E, that is x become minus iota f naught upon omega into Zm into e power phi into e power iota omega t. So, e power iota omega t is already there, and I have put this Zm as Zm magnitude and e power iota phi, or finally this x will become, this x will become minus iota f naught upon omega Zm, its magnitudes, and this is e power iota omega t minus phi, because it is iota omega t and it will go on numerator part and finally get minus phi. So, this is the exact solution of forced mechanical oscillator equation. So, this is the final answer, that is the value of x. So, we will proceed further with this value and we will find number of parameters, that is amplitude, phase, velocity, acceleration, power, etc. Thank you very much.